Hello everyone, my name is Mohammad Tanvir Alam and I am a student of Alia University in second year BTech. Today our topic is brick. So let's start. Brick, a small rectangular block typically made of fired or sun-dried clay used in construction. A brick is rectangular in shape and of size that can be conventionally handled with one hand. Brick may be made of burnt clay, a mixture of sand and lime, or of Portland cement concrete. Clay bricks are commonly used since these are economically and easily available. Size of brick. Here a standard size brick size 19 cm into 9 cm into 9 cm. Nominal size, size of brick along with mortar. 20 centimeter into 10 centimeter into 10 centimeter. Conventional size of brick 22.4 centimeter into 11.4 centimeter into 7.6 centimeter. Country bricks या field bricks. Classification of brick. Brick on the field practice: first class brick, second class bricks, third class brick, fourth class brick. On the basis of strength: class 3.5 to 35 MPa. On the basis of use: common brick, facing brick, engineering brick. On the basis of types: solid, perforated, hollow, cellular. Composition of brick: silica 50 to 60%, alumina 20 to 30%, lime 4 to 5%, iron oxide 5 to 6%, magnesia 1%. First, silica. Silica prevents the cracking, shrinkage and warping of the bricks, thereby imparts uniform shape to it. It decreases shrinkage in burning and increases refractoriness. If it in excess, it destroys cohesion between the particles, hence bricks become too brittle. Second, alumina. Alumina impacts plasticity to the brick earth so that it can be easily molded in any designed shape. If it is in excess, it causes shrinkage and warping during the drying of the bricks and makes the bricks too hard during the working process. Third, lime. Lime also prevents the shrinkage of the bricks. It helps silica in clay to melt and helps in binding, but if it is in excess, it causes the bricks to melt during the burning. Thereby, it results in loss of the shape of brick. Note: during the burning of the bricks, calcium carbonate is converted into quicklime that undergoes slaking process, which in turn results in the cracking and disintegration of the bricks due to increase in volume. Fourth, oxides of iron. Oxides of iron helps silica and lime to fuse with each other, hence leads to the development of strength in the bricks. Excess of iron makes bricks dark blue. It also imparts reddish brown color in the bricks, improves impermeability. Fifth, magnesia. Magnesia also prevents the shrinkage in bricks and imparts yellowish tints in bricks. Harmful ingredients in brick. Lime. First, lime slaking. Slaking volume increases, cracking and disintegration. Change the color of bricks from red to yellow. Second, iron pyrites. Presence of the iron pyrites leads to crystallization and disintegration of bricks during burning due to the oxidation of these pyrites during burning process. The brick may split into pieces. Third, alkalis. Alkali act as a flux during the burning of bricks, but if it is in excess, it causes the bricks to fuse with each other, thereby resulting in its twisting and warping. Presence of alkalis also leads to efflorescence and staining in bricks. Fourth, pebbles and stones. Presence of stones and pebbles brick earth leads to the formation of weak and porous bricks, load carrying capacity of which is comparatively reduced. Fifth, organic and vegetable matter. Presence of organic and vegetable matter helps in the burnings of bricks, but if they are left unburnt, it results in the formation of gases during the decomposition, which when escapes through the body of the bricks leads to the development of numerous voids, which results in decreasing of loads carrying capacity of bricks. Manufacturing of bricks: first, preparation of clay; second, molding; third, drying; fourth, burning. First, preparation of clay and soiling. Top 200 mm of soil is thrown and it is not as it consists of majority of impurity in it. B. Digging. Soil is dug out and spread over the level field to prepare it for next operation of cleaning. C. Cleaning impurities like stones, pebbles, organic matter, vegetation matter is removed from the brick earth. Deweathering. After cleaning the clay, it is imposed to the atmosphere for few weeks to few months for its softening, ripening, and weathering. Blending. It is process in which different ingredients of bricks earth is spread over the weathered clay in definite proportion and mixed. F. Tempering. Tempering is the process of which requested degree of hardness is induced in the bricks earth to make it suitable for the next operation of molding. Tempering of the brick is done in pug mill. Second, molding of clay. The process of giving desired shape and size to the brick is termed as molding. Steel or wood molds are used, size of which is approximately kept to be 8 to 12% greater than the size of the bricks in order to account for its shrinkage. During molding, a mark of depth 10 to 20 mm is placed over the surface of the brick. That is termed as frog mark, which serves following two purposes. First, trade name of the manufacturer. Second, if acts a cue for mortar when the layer of brick is placed over it. Molding of the bricks can be done with the help of hand or with the help of machine. Hand molding bricks are further of two types: A. Ground molded bricks. B. Table molded bricks. Qualities of table molded bricks incomparatively better than the qualities of ground molded bricks, and its rate of molding is also comparatively better than ground molded brick. Machine molded bricks are also of two types: plastic clay molded brick, dry clay molded brick. Quality of dry clay molded bricks is also comparatively better than plastic clay molded bricks. Third, drying. Molded bricks, if any, directly burnt without drying are too liable to get cracked due to excessive shrinkage. Hence, its drying is carried out before the burning of pressure, in which moisture content of the brick is reduced up to 2%. Drying of the brick is carried out either naturally or artificially. During drying, bricks are always placed along their edge and never placed along their face in order to speed up the process of drying. Fourth, burning of bricks. Burning impacts the strength and hardness to the bricks. It makes them dense and durable. Burning should be done properly. Overburnt, brittle, or easily broken. Underburnt, soft, or unable to carry designed load. Burning of the bricks is carried out at 1100 degrees Celsius, at which silica and lime fuse with each other, thereby imparting a strength to the bricks. Burning A. Clamps and B. Kilns. Fourth, burning of bricks. Burning occurs three stages: A. Dehydration या water smoking stage at 400 to 650 degrees Celsius. Water from pores is driven off. Some of carbonaceous matter is burned. B. Oxidation period 650 to 900 degrees Celsius. Remaining carbon is burned. Ferrous iron is converted into ferric iron. Sand is added to allow escaping of gases. C. Vitrification 900 to 1100 degrees Celsius to convert the mass into glass-like substance. For A. Burning of bricks in clamps. Trapezoidal section of ground is taken and lower side is raised with 15 degree. A brick wall is in mud is constructed along the shorted side, and the fuel layer having thickness of 700 to 800 mm spread over the level ground. Fuel used for burning of the bricks in clamps constitutes grass, rice, husk ash, wood, cow dung, coal, dust, etc. Burning of bricks in clamps. Burning of the brick in clamp is carried out 2 to 3 months. That is further following by its cooling for the same duration. No supervision is required in clamps. Moreover, since locally available fuel is used, the entire process is comparatively economical. There is no control over the fire in clamps. Hence, the bricks obtained are not of uniform quality. B. Burning of bricks in kilns. Kilns are large size oven that are used for the burning of bricks. Supply of the bricks from these kilns may be either be continuous or intermittent accordingly. They are classified as kilns. First, intermittent kilns. Second, continuous kiln. Intermittent kilns can be classified in two types: A. Updraft kilns. B. Downdraft kiln. A continuous kiln can be classified in three parts: A. Bull trench kilns. B. Hoffman's kilns. C. Tunnel kilns. First, intermittent kilns. All the operation of loading, burning, cooling, and unloading is done sequentially, and hence the supply of the bricks is not continuous from these kilns. Consists of two sets of main doors that are used for loading and unloading of the bricks. Bricks are placed in these kilns in the rows of approximately 4 to 5 brick thick and height of approximately 6 to 8 brick thick. An open space between the two rows of approx 2 to 3 bricks thick is left, which is used for placing the fuel. Intermittent can be classified into two types: updraft kilns. If the movement of the gases is allowed to take place in vertically upward direction, it is termed as updraft kilns. Second, downdraft kilns. If the movement of gases is allowed to take place in vertical downward direction, it is termed as downdraft kilns. In downdraft kilns, permanent roof is provided along with the central chimney that permits the movements of the gases in downward direction. Qualities of brick obtained from downdraft kilns is comparatively better than that of bricks obtained from updraft kilns. Second, continuous kiln. In continuous kilns, the supply of the brick is maintained to be continuous as all the operation of loading, burning, rolling, and unloading is done simultaneously. Continuous kiln. In continuous kiln, the supply of the brick is maintained to be continuous as all the operation loading, cooling, and unloading done simultaneously. A bull trench kiln. It includes two sets of movable chimney that are always placed ahead of the section in which burning is to be carried out. Such an arrangement allows the preheating of the bricks in the chamber over which chimney is placed. This kiln consists of number of sections in which all the operations of loading, burning, cooling, and unloading is done simultaneously. These kilns are generally oval, circular, and rectangular in plan. B. Hoffman kiln. This kiln is circular in plan and consists of fixed central chimney, unlikely but trench kiln that consists of movable chimneys. This kiln consists of number of sections in which all the operations of loading, burning, cooling, and unloading is done. C. Tunnel kiln. This kiln is in form of tunnel which may either be rectangular, circular, or oval in plan. It consists of different stationary zones in which all the process of loading, burning, cooling, and unloading is done simultaneously. Bricks are placed either on trolley or on conveyor belts and is passed through different stationary zones in the tunnel. Quality or testing of brick. For testing of brick, 50 bricks are taken at random for a lot of maximum 50,000 bricks. First, the brick should at least stable, molded, well burnt, and free from cracks. Second, dimension test. 20 pieces out of the selected pieces are taken and laid flat and checked for tolerance limit. The brick should be of uniform shape and size. Conventional size of bricks: 22.4 cm into 11.4 cm into 7.6 cm. Standard size of brick: 19 cm into 9 cm into 9 cm. With mortar: 20 cm into 10 cm into 10 cm. Weight of 1 meter cube bricks: 1800 kg. Weight of one brick: 3.5 to 3.6 kg. Third, soundness test. The brick should be produce clear metallic ringing sound when struck with each other. Fourth, structure test. The brick should have uniform homogeneous structure across all the sections. That means it should be free from any voids. Fifth, absorption test. The bricks, when immersed in water for 24 hours, not absorb water by more than 20% in case of first class brick, 22% in case of second class brick, 25% in case of third class brick. Sixth, compressive strength test. The brick should process Minimum compressive strength of first class 10 Newton per mm square, second class 7.5 Newton per mm square, third class 3.5 Newton per mm square. Seventh, toughness test. The brick should not break into pieces when dropped on level ground from the height of 1 meter. 8. Hardness या abrasion. The brick should possess sufficient hardness and does not show any sign of impression when scratched with fingernails. Ninth, alkali test. The brick, when immersed in water for 24 hours, should not show any sign of efflorescence and staining. Defects of brick. First, overburning of bricks. If overburnt, a soft molten mass is produced and the brick lose their shape, not suitable for construction purpose. Second, underburnt brick. It causes higher degree of water absorption and less compressive strength. Third, black core. When brick clay contains bituminous matter या carbon, and if it is underburnt, it causes black core. Fourth, chops. The deformation of the shape of the brick caused by the rainwater falling on hot brick is known as chops. Fourth, check या cracks. This defect may be cause of lumps of lime या excess of water. In case of the former, when bricks come in contact with water, the absorbed water reacts with lime nodules, causing expansion and a consequent disintegration of bricks, whereas shrinkage and burning cracks results when excess of water is added during brick manufacturing. Fifth, spots. Iron sulfide, if present in the brick clay, results in dark surface spots on the brick surfaces. Such bricks, though not harmful, are unsuitable for exposed masonry work. 6. Blisters. Broken blisters are generally caused on the surface of sewer pipe and drain tiles due to air impression during their molding. 7th, lamination. These are caused by the entrapped air in the voids of clay. Lamination produces thin lamina on the brick faces which weather out on exposure. Such bricks are weak in structure. Brick masonry. First, structure. Longer side face of the brick. Second, header. The shorter side face of the brick used for hurting of walls. Here different types of forms of brick. Rounded. First, rounded in a brick, cant brick, double cant brick, cornice brick, perforated brick, bullnose brick. Different forms of brick. Hollow brick, coping bricks, perforated bricks. Small holes may exceed 25% of the total volume of the brick. Hollow brick. The total of holes, which need not be small, may exceed 25% can of the volume of the brick. Brick masonry. Third, closure. The portion of the brick cut along its length. First, queen closure quarter, king closure, beveled closure, mid-rate closure. Fourth, bats. The portion of the brick cut along its width. Fifth, coin. It is the exterior angle at the face of the wall that is greater than equal to 90 degree. First, bonding in brick masonry. First, English bond. Alternate layer of hair and header and stretcher placed over each other to break the alignment of vertical joints to be in a straight line. Queen closure is placed next to queen header. Queen closure is never placed either at a starting or at the end of the course, as it is liable to get displaced. English bond. For the walls having the thickness in odd multiple of half brick, each course shows header on one face and a stretcher on other face. Minimum lap available for a stretcher in each course is 1/4 the length of brick. Here this picture. Second, Flemish bond. It is the arrangement of bonding in which each course consists of alternate header and a stretcher placed next to each other in order to break the alignment vertical joints to be a straight line. Queen closures is placed next to queen header in each alternate course. For walls having thickness in odd multiples of half brick thick, English bond is found to have higher strength than Flemish bond. Flemish bond is aesthetically more pleasing than English bond, but it requires a skilled masonry works. English bond has more strength than Flemish bond. Flemish bond is found to be more economical than English bond, as number of half bats is used in case, due to which wastage of brick comparatively less. Here this picture. Third, stretcher bond. To break alignment in a stretcher bond, half bands are used. It is an arrangement of bonding in which all the bricks are laid along the stretcher. In order to break the alignment of vertical joints to be in a straight line, half bands are used in each alternate course. Fourth, header bond. It is the arrangement of bonding in which all the bricks are laid along the header in each course. In order to break the alignment of vertical joints to be in a straight line, their quarter band is used to each alternate course. Some important clay product. Thank you.